Okay, so the first thing I'm going to do is I'm going to get the time that the baseball has to rotate. And I'm going to get it from the linear information. So I'm going to use the formula V equals distance divided by time to solve for time. So time is distance divided by V. And the distance that the baseball travels from leaving the pitcher's hand until it's caught by the catcher is 16.5 meters. So that's going to be your D. And the speed of the ball certainly determines how long it's going to take to get there. So the speed of the ball is 42.5 meters per second. And notice the meters will cancel out. I'll be left with seconds in the denominator of the denominator, and that's going to get me my time. And what do I get for that? What's my time? 0.388 seconds. So there's my time. Now I want to figure out, it says what's the tangential speed of a point, so I really need to know what the angular velocity is of the baseball, which I can get because, so I'm looking for the omega, which isn't going to change. The original is going to be the same as the final because it's not saying anything that as the ball's rotating, it's going to start slowing down, which in real life it would, right? I mean, if it didn't, like if I spin a basketball on my finger, if it didn't slow down, I could stand there all day and just look at it. You have to keep hitting it to keep it spinning. So the omega original is really what I want, which is the omega that I'm going to have in the formula V equals R omega. So this is going to be the unknown right now, which will be radians per second. The alpha we're going to say is 0. And like I said, in real life, it wouldn't be 0. It's going to slow down. We now know the time. So the time is 0.388 seconds. And we we know the theta. So the theta is 49 radians. So that's how much it actually rotates in the time to get from the pitcher's hand until the catcher catches the ball. Yes. I mean, that's what I'm going to end up doing, but I'm using the formula that, I'm still sticking with rotational kinematics, and these would be the, it ends up being that because alpha is 0, but it's coming, what you're telling me is coming from this. I mean, I would accept that if you had that for a problem like this. So my equation is going to be theta equals omega original t plus 1/2 alpha t squared, and that whole thing cancels out because it's 0. So if I'm solving for the omega O, it's going to be theta divided by t. So, when we learned these things back when we did straight line motion, I was very particular about you learning the steps. But if you get to the point where, I'm not numbering them anymore, and I'm pretty much going right from the algebra right to now plugging in. So I'm sort of like combining 3 and 4 together. It's just when you're first learning it, I want to make sure you get the steps down, and then if you can take a couple shortcuts, you're able to do that. So 49 radians, and that's going to be in 0.388 seconds. And what does that work out to be? 126 radians per second. So that is I'm calling it omega O here, but that is the omega. The omega isn't changing. So now knowing the baseball's radius, I can get the tangential speed of a point on the equator of the baseball. And it is important that it's on the equator, right? Because if it's literally on the axis of rotation, the tangential speed would be 0. Right? It would be 0 on the axis of rotation as the ball's spinning. The tangential speed does differ depending on where you're talking about, what part of the baseball you're looking at as it spins. So we're going to, at the equator, we can use the radius of the baseball, because at the equator, that's what the distance would be from the axis of rotation. So I'm going to use the formula V equals R omega. And I don't have to rearrange it. I'm solving for V. The R would be, what was it? So was it 0.03? Or let me look back up here because I don't know what did they give me. They gave me the radius, so that's going to be 0.0367 meters. So 0.0367 meters times 126 radians per second. So again, to show how radians cancels out, that's really what a radian is for this problem. And so the answer will be in meters per second. And what is 126 times 0.0367? 4.62? Is that the answer I gave you?